is the function g continuous at x equals -2? I went ahead and attached a graph of this function. As you can see, this function is not continuous at x equals -2 because the left piece is up at +2. See? The right piece is down at what? -3. So this function is not obviously continuous at x equals -2, but how do we prove that using the definition of continuity? So in order to do that, we're going to do this in 3 steps, okay? Number 1 is, what's the name of this function? F. Is f defined at the given value x equals -2? If it is, we're going to find out what that value is, okay? What do we do? When x is -2, we should go with the bottom expression, right? Because it says x is greater than or equal to, because of this equal to bar underneath, we are going to plug in -2 in here, okay? So x minus 1. If you plug in -2, you will get -2 minus 1. So the function value is -3. I'm going to write that down over here. Yes. F of -2 is equal to -2 minus 1, which is -3. So you write that down and keep it because we are going to use this to make our conclusion later, okay? So I found out that f of -2 is -3. That's where the function is at -2. That's where we have this open, the closed circle, right? The function is defined down here at -3. Now, the second thing that you're going to have to find is the limit. And that's going to be like 2-part on its own, okay? Does limit as x approaches -2 of f of x exist? If it exists, what is it, right? So let's find that out. Well, this is a piecewise function. So if you look at this graphically, and we're going to have to do this algebraically, but if you look at the graph of it, the left piece right here, as this is approaching -2 from the left, is going up to +2, right? It's going up to +2. The right-hand limit, though, as it is approaching -2, this x value of -2 from the right is going down to -3. Obviously, 2 and -3, they're different. So the left-hand limit is 2. The right-hand limit is -3. They're not the same. So the general limit does not exist because these are different. Well, we have to write that down, okay? And assume that we don't have a picture. When you're taking this on the exam, when you have this kind of question on the exam, you're not going to have a picture. So how do we do that algebraically, okay? And what we're going to do is we're going to plug these into these 2 pieces. So for the left-hand limit, use that red highlighted part, okay? Because to the left of -2, we're using this half x plus 3. You know what? I'll write it down here and I'll move the work down, okay? Limit as x approaches -2 from the left of f of x is equal to half times -2 plus 3, which is -1 plus 3. That comes out to be 2. And that matches what we see on the graph, right? So the left-hand limit, using this piece right there, is +2. Now let's find the right-hand limit, okay, using this piece. Okay, limit as x approaches -2 from the right of f of x is going to be -2 minus 1, which is -3. Okay, and look, that's where we had this point at, right? -3. Obviously, left-hand limit and the right-hand limit are different. When I say these are not the same, not the same. So guess what? The general limit does not exist. I'm going to write that down here, okay? I'll say that no, because, let's abbreviate. Left hand limit does not equal to right hand limit as x is approaching -2. Okay, if we write that, I'll understand what you mean, because we have this work up here. We found the left-hand limit in red, we found the right-hand limit in green, and we saw obviously they are not the same. If one-sided limit, left-hand, right-hand, if they're not the same, the general limit does not exist. So here's the conclusion. In order for a function to be continuous at this point, we gotta have the function defined and the limit has to exist, and they have to be the same. Well, unfortunately, we're gonna have to say f is not continuous at x equals -2 because the limit does not exist at -2. Limit of f of x as x approaches -2 does not exist. In order for it to exist, we need to compare these function value and the limit, and they have to be the same. But if it doesn't even exist, we can't compare, okay? So that's why the conclusion is that this function is not continuous at -2.